Hello everyone, my name is Sheikh Ayub Malik. Today I am going to discuss about addressing modes. I am from 2CSCD after the number 5K6. So let us get started. In order to perform any operation in the processor, we need to have the data and instruction, right? So in order to access the data or instruction from memory, we need its address. For this, for the sake of accessing the data, we need its address. There are many ways which we specify the location or the address of a operand in an instruction. That is called addressing mode. Basically, there are different types of addressing modes. They are immediate, register direct, register indirect, absolute, indirect, index, auto increment, auto decrement, and relative addressing modes. Let us get started. The first one is immediate addressing mode. This is the simplest of the addressing modes. Here, we simply indicate the value which we are going to send in a memory location. The value is directly the content. We are not specifying any memory location here. We are not specifying any variable or address here. We are just basically representing the data with the help of hash. So what I'm doing is move hash comma b, move hash 6 comma b. So the value 6 will be stored in b. So this is the simplest one of the addressing modes. The second one is registers. We all know that we have general registers in processes right from R0 to Rn minus 1. So this is the second type. Add R0 comma R1. The content of R1 is going to be added to the content of R0 and the result will be stored in R0. So basically here R1 is overridden because the at the last moment the value of the sum of R0 and R1 will be written in R1. So R1 is overridden and R0 is stored. The third type is register indirect. So basically in this register direct we have contents directly placed in R0 and R1, but in register indirect in R0 we have an address. That address contains the operand. I mean, in R1 we directly have the operand, but in R0 we have the address of the operand. So if you access R0, you will have the address. You have to again access the address in order to get the operand. So that's why the address is represented by in parenthesis of R0, comma R1. The fourth one is absolute. So this is the simple. This is also a simple one. So basically, two memory locations. This is also memory locations, but they are registers. But these are direct memory locations presented in the memory, sorted and organized. So here A is one memory location and B is one memory location. Move A comma B specifies the content of A will be moved to B. The other one is absolute indirect, which means this is similar to the register indirect. So the memory location A will have the address of the operand, but while B has directly the operand. So move parenthesis of A comma B means the address that is present in A has the operand that will be moved to B. Next one is index. The effective address is calculated by adding offset value to the contents of register. So the basic representation of index addressing mode is x of r1. X is the offset or index value. So what is effective address? We have been discussing the same thing in our seminar from the start. Effective address is the place where you can access the operand. So here effective address is calculated by offset value plus contents of register. Base index is adding the contents of two registers. Base index with offset is adding the contents of two registers plus offset value. The next one is auto increment. So auto increment is nothing but the general general register. What happens is the value of register is incremented by one after fetching the operand. So if you fetch the if you're trying to access an operand, so after performing the execution, the value will be incremented to 1. After the execution, it will be incremented. But auto decrement is before even performing the operation, before execution, the value will be decremented. First, let's say here the value of R register RI is 100. So after accessing the location, it will be incremented to 101. But auto decrement is um, before even accessing it, it will be decremented to 99. General form is x of, sorry. From here, this is PC addressing mode, relative addressing mode. So what happens is the general form is x of PC. PC means program counter. That is also a register present in processor. So the effective address is x plus PC, offset value plus PC. From here, it is relative addressing mode, the last type. General form is x of PC. PC means program counter. Program counter is a register which point out to the next instruction. The effective address is x plus PC. So here's the table of contents of addressing modes, their basic notation, and the effective address. Effective address is the address where the operand is present, right? So immediate, register indirect, register direct, absolute, indirect, index, auto increment, auto decrement, relative. This is all about addressing modes. Thank you.